Okay, guys, this is the last section of the first quarter. So after that, we are done with the first quarter, and we'll have a Chapter 3 test, and then we'll have the first quarterly assessment. So this section, 3.3, is all about conditional statement. All right, a conditional statement is any statement in the if-then form. So, for example, we can think of, if it is Monday, then I am tired. If someone talks about Chipotle, I get hungry. Now, even though there's no then, that comma still is a then. And to relate it to math, if 2x plus 3 equals 13, then x equals 5. So you guys can kind of see how we've been doing this stuff, and we're starting to get some math involved. What I want you guys to be able to do is change each statement into conditional statements. So be able to take a sentence and turn it into a conditional statement. So if you look at these, if you want to pause the video and try it on your own, but we'll go through these. Alright, first one, an equilateral triangle has 3 congruent sides. Several ways to write that, but I just put if a triangle is equilateral, then it has 3 congruent sides. Just kind of keep it simple. The next one, I always go to movies on Friday. Sometimes it's easier to switch it around, so I put if it is Friday, then I go to the movies. No, there's not really, as long as you're not adding anything to the sentences, that's fine. Pretty much all you need to do is put an if and a then in there, and that's it. Now there's parts of conditional statements that you guys will have to be able to recognize. There's 2 parts, the hypothesis and the conclusion, and you'll need to know what they are. First off, the hypothesis. It is the P part of our problem, if you guys remember from the truth tables. It's everything after if and before then. Here's the big thing. You do not include the if or the then. It's the stuff in the middle of the if and the then. That's the hypothesis. The conclusion is pretty simple. It's the Q part, and it is everything after then, and do not include then. Now, when we start to look at this as in symbolic notation, it might look something like this. P then Q, and just to remember, the P part's the hypothesis and the Q part is the conclusion. Now that's going to be important how we write the symbolic notation for the next part. But first we'll need to be able to take a sentence, and I want you guys to label the hypothesis and the conclusion. So if we have, if I need to talk to my friend, I will send her a text message. Well, the hypothesis is everything after the if and before the then. And remember, the comma takes place of the then. And the conclusion is everything after the then. So our answer would be hypothesis, I need to talk to my friend. Conclusion, I will send her a text message. Pretty simple. Well, there's different types of conditional statements, and there's 4 of them that we will focus on. The first conditional statement we will focus on is just a conditional, and that is if we do P, then Q. Alright, so just keep it in the same order that it is stated. Then the next one we're going to talk about is the converse. The converse is Q, then P. So we are to switch it around. Like Converse shoes, they're always switching their colors. We're going to switch it around. Now the inverse is not P, then not Q. So we're going to take the original conditional statement, and we're just going to put negations on both of those. Now the last one, the contrapositive, I guess you can probably figure out is going to be the mixture of those two. It's not Q, then not P. So we go ahead, we switch it around, and we negate it. Now let's show what a problem like that would look like. First, we need to know a counterexample. A counterexample must be true for the hypothesis and be false for the conclusion. So what we're going to do, we're going to take this conditional statement and write out the conditional, the inverse, the converse, and the contrapositive. And the statement is, if a shape is a square, then it is a rectangle. We're going to find the truth value of each, and if it's false, give a counterexample. So let's start with the conditional. If you guys want to pause the video and try to figure these out on your own, you can. I'd suggest it. But let's go through these. So the conditional stays how it is, and I just simplify it. If it's a square, then it's a rectangle. And as you guys remember from geometry, that is true. So nothing else we need to do. Alright, let's move on to the converse. The converse, we switch it around, so I said if it's a rectangle, then it's a square. Well, that is false. Now here's the thing, we can't just say it's false. We need to give a counterexample so you can write about it or make your life easier. I'm just going to draw a rectangle. Here, this shows something that is a rectangle but is not a square. So it's true for the hypothesis but false for the conclusion. Alright, the next ones I'm going to do on the next slide. Inverse would be if it's not a square, then it's not a rectangle. So we take the conditional and we just negate it. Now, that is false. So we'll go ahead, draw another example. Here's something that is not a square, but it is a rectangle. So it's true for this, it's not a square, but it's false for this. It is a rectangle. Alright, the last one we'll do would be if it's not a rectangle, then it's not a square. And that would be true. Alright, anything that's not a rectangle, there's no way it could be a square. Alright, so that concludes this lesson and this chapter. So good luck for the next two assignments. Just like before, you guys will download those and submit them. And we got the chapter test coming up, so good luck on that.